All right. Good morning, everybody. Welcome back to Comp 2452. I hope you all had a better weekend than I did. My weekend was pretty bad. Everybody in my house was sick. We were all just like, yeah, not doing much. We watched this movie on Sunday called Howl's Moving Castle. I don't know if you've seen this before. Oh, wow. Okay, my daughter, we were worried, like, as we were going through it, that she wouldn't watch it because, like, I don't know, I've never seen any of these movies before, these Studio Ghibli movies. I've never watched them. And there was some really weird stuff happening at the beginning of that movie. Like, there were these black blob creatures that were just, like, kind of going through this town. But I don't know, it was really fun. We watched it with the English dubbing. Mainly because as soon as my daughter heard them just, like, speaking Japanese, and she doesn't know what they're, I don't know, I don't speak Japanese. She got mad because she didn't want to read the whole movie. So, like, I'm gonna have to build this into her over time, of course. I think it's important that she's able to read subtitles. But the voices were done by people I wasn't expecting. So, like, there's a little fire creature demon that's voiced by Billy Crystal. Which was just, like, really unexpected to show up in this movie. But the most unexpected thing for me was that Christian Bale was the voice of one of the characters, and Christian Bale is famously Batman, and so every once in a while, this character would just have this, like, gravelly voice put on, and it would be like, hey, it's Batman in this movie, and then suddenly it's just like Christian Bale's regular voice again. And so that was, I don't know, we were sick, but it was a nice way to spend kind of a lazy Sunday afternoon. So yeah, I don't know, that was nice. It was nice, but it wasn't a great weekend because everybody was feeling pretty sick. Feeling better now, but you know, still coughing going on in my house at nighttime. And this is a very unrelatable story, but interrupted sleep at night because of children coughing is much worse than just having less sleep to begin with. Like, going to sleep later and waking up earlier is better than having be woken up twice throughout the night. Anyway, off of completely unrelatable stories. This week we're going to keep on keeping on with sequel. The goal for this week, where the last couple of weeks have been kind of focusing on design. So, like, starting to take some of the ideas that we have with class diagrams, and without a lot of context, we started making changes to those class diagrams. But the context ultimately was, we're actually trying to represent these things that we're now doing with our relational databases and tables in the context of these class diagrams. So we're trying to add extra information like cardinality, and we're trying to do things like have these bidirectional relationships between classes, ultimately because we can't have arrays as columns in the tables that we've got. So rather than having arrays of columns, let's just invert this relationship so that we can put an entry in the table that has the one side of that relationship as opposed to having the many side of that relationship. So what we did last week was take this idea of a trainer and the team of Pokemon that they have. And at least in JavaScript and Java, our trainer has an array of Pokemon, but in the relational tables that we've got now, the way we're representing this array is that the Pokemon has a trainer, just one trainer. It has a trainer, but we're able to reconstruct that relationship from that inverted relationship between those two things. We also added things like uniqueness. So we really can't express this appropriately in an objects model. There's no good way for us to say that you can only ever have one instance of this thing that has this specific value. We can express not nullness, and we have been doing that using type assertions with TypeScript and previously with design by contract with Java. But once we did all that, we then moved on to, like, let's build up these tables using SQL and kind of visualize those tables, but it was pretty disconnected from our actual code. Let's just focus on doing SQL stuff. This week, what I want to focus on is I want to keep thinking about SQL, so I want to spend more time doing the queries, so like writing updates, writing selects, writing inserts, that sort of thing. But I also want to put this into the context of how do I actually take this SQL stuff and actually interact with it from a TypeScript or JavaScript code base. So how can I start taking this idea of relational databases and begin to integrate that into my application? This week, we will also begin to think about some of the consequences of that. So like, what are the issues that can come up with certain kinds of data that we would put into a relational database? So I'm thinking specifically around things that are like representing people and representing identification for people. So like, how do we authenticate ourselves against systems? And the kind of risks that we can have when we're working with SQL databases in ways that are typical for programming languages. So when I'm using SQL queries, I'm not often going to be writing queries that are just hard-coded. I'll have those. I will absolutely have those in my system. But more often than not, I'm responding to user inputs. I want to insert something into my database that has values that somebody has actually typed in on my web page. I want to use a nickname that you have provided to me for my Pokemon rather than me just always telling you what that nickname is going to be. And there are issues with that. Blindly accepting input from people and inserting that into databases is going to cause problems for us unless we account for the fact that they can type in things that we're not necessarily expecting them to type in. So we'll start to think about that on Thursday's class. Some additional information for you just to give you a sense of when you should expect to get the term test results back. I'm going to be able to grade those over the reading week break. So that's when you should expect to start to see those results. And then for the design part for phase 2, I'm planning to have that available before class on Thursday of this week. So you should expect to see that showing up on the course webpage, and then we'll talk about it in class on Thursday. Yeah.
Will you be grading all the midterms, or will there be other grades?
I'm going to be grading all the midterms, yeah. But I unfortunately just don't have time to do that until the reading week break, yeah. All right. Okay, so by the end of today's lecture, what I'm hoping for you to be able to do is I want you to continue to be able to create, populate, and query data in a database. Some of this is going to be that I want to add some more information to the toolkit that you've got for being able to create tables. One of the things that we've done so far in this course is I've kind of told you, like, these are appropriate unique values for these tables to have unique entries, but we don't always have those unique properties on classes and instances that we can use, so we'll have to do something about that. And I also want to be able to represent the idea of ownership. So thinking about what happens when I delete or make changes to records, how is this going to affect the other tables that are referencing those things? So we'll think about that. And then beginning, I want you to be able to start to use a programming language to interact with the database. Our focus today is going to be purely on, I want to be able to get the database set up in an application. We may or may not actually start to write queries in the context of our programming language, but the main thing that we're going to want to do with this is I want to start setting up the database so that my web app can begin to interact with it with a web page. So with that, let's start doing that. The first goal that I have for us today is I really want us to be able to start integrating this read eval print loop into our application. Up until this point, what we've been doing for this read eval print loop is that we've been going really to this PGLite website and then starting to interact with this kind of link on their page. This is their hosted version of this read eval print loop that's letting us do things like create table and insert and select and so on. But one of the things that they provide for us is, if I go to the docs here, and we'll come back to this page in just a moment, is that we can actually take this REPL component and just embed it in our own thing. We can take this thing and put it into our own web pages. Our parents are not going to interact with this REPL. This is going to be a tool for us to use so that we can actually inspect the state of the database that we have in our systems. But this is a first step toward let's get this integrated into our applications. So I'm going to go back to my slides here briefly, and we're going to kind of be going back and forth between slides and our code base today to get this all set up. But the goal here is that I want to be able to get this REPL integrated into our app so that we can create tables here with constraints and references. so that I don't have to constantly type in create table. You've seen me do it at least twice now. You're going to see me do it one more time today at least, but I don't want to keep doing that. That's going to be painful for all of us if I just keep typing in create table every time. So let's start getting this set up in a way that's going to be kind of reproducible. So I'm going to be working from the repository that I've shared with you throughout the course. So if you want to follow along with me in this setup, please do. But the stuff that I'm doing today, at least getting this REPL integrated into the app, is not specific to this app. This is something that you could reasonably follow along with in your own projects if you want to. So first things first, I'm actually going to quit out of LazyVim here. And I want to start by interacting with the project kind of at its root level. pglite is a dependency that we are going to install into our application. So far, the only other dependency that we've installed into our application is vtest itself. So if I cat this package.json file, we've got other stuff here like this coverage, TypeScript, vt, and vtest. The only thing that we've actually installed explicitly is the vtest dependency. But we're just like with Maven, and I'm updating our POM file, we want to have more dependencies than just this. pglite is a fully integrated relational database software management system. So this is a database that's called Postgres. So if you're looking at other relational database management systems, PostgreSQL is a pretty common relational database management system. pglite is a fully embedded in your web browser instance of this. So we don't have to connect to any remote servers to be able to work with this. So I'm going to go back to the getting started here, and we want to install this as a dependency. So I'm going to copy this command, and I'm going to run it in my terminal from the root directory here. The one thing I want to note about the npm install command here is that I'm not saying that this is a dev dependency. So if I cat package.json again, this is now not listed in the dev dependencies. This is listed in the dependencies of our application. Dev dependencies are ones in Node that are used kind of like at compile time. This is really only there for when you're doing development on your application. When you give it to your parents or when you put it up on a web page, these don't come along with your installation of that application. Dependencies here are ones that you want to actually bundle in your application. This is a necessary part of the application that you're working with. This concept of dev dependencies and dependencies doesn't really exist in Maven. There's a sort of concept of it in the sense of like test dependencies versus regular dependencies, but it's otherwise kind of just all the same thing. I'm going to go back to my web browser here, and I'm going to skip along here to the next slide. And I'm going to ask you just politely to blindly accept that we are adding this file to our projects. The short of this is that vt, by default, will do optimization passes on dependencies. So it's doing things like taking your JavaScript files and minimizing them, for example. So making them smaller so that when your web browser is requesting them from a server, it's requesting less data from that web server. We want to exclude this pglite from being optimized. We don't want to actually have that happening. I don't want it to do that. And so this is some magic text that will cause that to happen. It will make sure that it's not actually going to optimize this. If you find that when you are opening your app after you've started to integrate this stuff and you look at the console and it says something to the effect of fs size is not equal to something, 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 this is the solution to that problem. I can't claim credit for this. I found this on Stack Overflow. I'm accepting that this is the solution to the problem because it fixed the problem for me. So I am going to copy and paste this code. And the file that I'm going to copy it and paste it into is vt.config.ts. So I'm going to add this vt.config.ts to the root of my project, and I'm just going to paste that in there. Now what I want to do is I'm going to start making a new page for this REPL. I again want to be very clear that this is what we're doing for this course is a single page application that's local first. We don't want to interact with web servers. We don't want to go in between many different pages. Our controller should really just be making changes to the page that we have on the screen right now. But this is for us. This is for me and you. This is not really part of our application. This is something that I want to be able to use to interact with the database that we're going to be working with. And so what we're going to do is make a new file that's called repl.html, and we're going to replace the contents of the index that we've got right now in our system with some sample code that comes from the PG Lite documentation. So I'm going to pop over to my terminal here again. I'm going to copy this file that's called index.html, and I'm going to call it repl.html. So I've got two files here that are identical. What I want to do is I want to replace the contents of the body with the stuff that's on that page. So I'm just going to delete all this. We don't need our own app main.ts in here anymore because that's not what's happening with this page itself. And I'll also change the title here just so I know what I'm doing when I've got this tab open. This is going to be the REPL that we're working with. And I'm going to go back to my web browser. I'm going to pop open this link here. This is, if you go to docs and then REPL component, this is under the web component section here. This is a direct link to web component. I'm just going to take all of this. I'm going to copy it, and I'm going to paste it into this file. I'm going to write this out, and then I'm going to open up another terminal here, and I'm going to run npx-vite. And I'm going to open up my web browser to this link. And what I'm going to do here is I'm going to change the address that I'm going here. I'm not just going to go to that link directly, but now I'm going to repl.html. And so what I've got here now is I've got the REPL. I have this REPL that I'm now able to begin to interact with. And so I can do things like create table, Pokemart here if I want, and I can say name varchar 255, not null, unique. Whoops. And we're able to start interacting with this database now in very much the same way that we were doing it with the web page that we had for PG Lite itself. This is great. I hope, yes, you are approximately at the same spot as me right now. Yes, yes, yes. 4 of you are, and everyone else is doing other homework. Awesome, okay. Not everybody, forgive me. For people who are on the stream, nobody is doing other homework in this room. They're all paying 100% attention to me right now. Yeah, good, good. We've got the REPL up on the screen. We've got this new page in our app. Again, our parents are never going to come to this page. That's not the goal. We want to be able to use this page for us so that we can actually interact with the database that we are setting up. What I want to do with this is make a couple of changes to this code so that we can actually start to interact with it in such a way that this will populate our database with tables. It will create the tables for us so that we don't have to type in create table every time. So the very first thing I want to do to that task is I'm going to add a new file to my repository here. And the file that I'm going to create here is called createtables.sql. This file is going to be the one that I use to start writing in my DDL. I don't know if I've used that acronym yet. DDL is Data Definition Language. It is SQL, but this is all of my create table statements. This is me starting to write the code to get the table set up in the system that I want to interact with. So I'm going to open this file, and I'm going to rewrite these create table statements. I'm just going to do it. I'm not going to dwell too much on what I'm typing in here. We've gone through this a couple of times. I just want to have this in the file that we've got right now. So I'm going to create table Pokemart. Pokemart has a name, varchar. It's a string. It's not null, and it should be unique. I want to be able to create table trainer. Trainers have a name. They are not null, and they are unique. Trainers also have a favorite mart. It's of type string because we're going to refer to the Pokemart table's name, and it can be null, and it doesn't have to be unique. And I want that to be a foreign key, so on another table, it refers to the table trainer, Pokemart, sorry, and it refers to the field name on that table. The last table that I want to make here is Pokemon. Pokemon have a nickname. It is not null and unique. They have an HP, which is of type number. It's an integer, and it's not null. They have a trainer. We're going to refer to the trainer table here, so we want it to be string. We want it to be not null, but it's okay for it to not be unique. We want to have a trainer having more than one Pokemon, and we're going to have a foreign key on the trainer property in this table, and this is going to refer to the trainer table, and it's referring to the name field on that table. That's a great question. How can we write comments here? The way that we write comments in SQL is to put two dashes right next to each other. So this is creating the Pokemon table, refers to each Pokemon row is owned by a specific trainer. I'll come back to that in a minute. So we have achieved a new achievement here, Sugar Rush. We've had 30 coalescing sugar lumps. Oh, and for the record, I did actually get to 1 quadrillion cookies that afternoon. I did actually manage to buy that upgrade for the afternoon class, so I'm delighted. And so what we'll buy this morning is this designer cocoa beans. Research will start to get weird after a little bit. One thing I forgot about this game, no, I'm not going to spoil it. I'm not going to spoil it. Something's going to happen in a little bit that's going to be kind of weird. But we still have 10 quadrillion cookies, and so I'm going to buy, let's buy 1 prism here. Let's buy 2 prisms here. Okay, so we've got lots and lots of cookies. We're making 50 billion cookies per second right now. That's pretty fast. That's lots and lots of cookies. Okay, so we've got this create table file now. We have this thing that is really going to have the responsibility of setting up the tables that we have in this database. I'm going to open up to the side here my REPL.html. And what I want to do with this is I want to start interacting with the database. There's a couple things here that look kind of similar to what we've done before. There's a script reference here. This is to a specific web page. This is actually loading that JavaScript file from the web. That's fine. We could change this so that it loads something from our local database or our local server, but whatever. Let's just accept that this works for what we're doing right now. there's this thing that's a tag that's called pglite-repl. This is not an actual HTML tag in the HTML language. This is an element, but it's a custom element that has been defined by pglite. pglite has made this element, and what it's doing with this element is it's taking that element as we're loading it here with document.getElement by ID. This is the same as query selector and passing a number sign in front of it. And it's really turning that element into this complex structure that it's allowing us to type stuff into it. Beneath this, we've got this import statement. This is functionally identical to the import statements that we've been writing before. Here, we're making an instance of this database. And here, we're connecting that database to the REPL. So now we're saying that the REPL that's running in my web browser right now is going to be backed by this instance of the database that we're working with. And so what I want to be able to start doing with this is executing statements to that reference to the database that I've got. The first thing I'm going to do here is I want to load the file that I've got here that's called createtables.sql, and I want to load it into a string in this script. So just below this import pglite line, I'm going to add another line, and I'm going to say import ddl from. So the structure of this so far is the same as a regular import statement. But now what I'm going to say is /. So from the current directory, I want to load the file that's called createtables.sql. I'm going to put $raw after this. This is taking the contents of createtables.sql from the current directory, and it's putting it into a string. The string is a variable that we can now use in our code, and the string's name is ddl. Just below this const pg, I'm going to say console.log ddl. Just want to see what this is. So I'm going to write that out. I'm going to go back to my web browser here. We'll click off of cookies. We'll open up this REPL again, Control-Shift-R. I want to inspect the output here. I want to look at my console. And I've logged it. I've read that file in, so this is very convenient for us. I don't have to do a bunch of file reading stuff with the file system. I can just load this in as a string from the current directory, and I can dump it out into console log here. That's cool, but that doesn't actually let me load my database. And so I'm going to go back to my page here. And what I want to do with this ddl, once I've got it, is I actually want to say, run all the statements in the file on the database. So I'm going to say this, db.exec. So db is the name of the database that we have a reference to. Exec now is a function or method that we can call on this object to say, I'd like you to run these queries, please. And the queries that I want to run are what's contained in this string that's called ddl. So this is populating the table structure in my database. I'm going to go back to my web browser now. I'm going to save this first, and then I'm going to go back to my web browser. Whoops, DB is not defined. Thank you. Thank you, console log. This should not be DB, this should be PG. I'm going to go back to my web browser now. And what I should be able to start doing here is in my REPL, I should expect that. I'll come to you in just a second. In my REPL, I'm expecting now that I have entries that are tables that represent what's inside that file. Yeah. So in the context of your projects, when you're starting to use databases, what I'm ultimately expecting you to do is to persist instances of these classes. Yeah. So persisting instances of the classes that you've got, and then all of the relationships that you have between those classes. So if you're doing the clicker game, it would be like persisting the game state and all the upgrades that you bought. If you're doing the point of sale, it would be persisting carts and receipts and all the products that are in those carts and receipts.
I'm just trying to think of like, need to actually create the upgrades in advance so that they're already existing in the game so that they can be bought.
Yeah. So the question is about there kind of needs to be some stuff in the database just to begin with. And that's fair. That is super duper fair. If there needs to be something that's in the database when you're starting, the right place to put that would be actually right here in this create tables SQL file. So, or in another file and just load them both separately. So after creating the tables, we could load some default data into our database. So I'm going to say, for example here, insert into Pokemart name values Mountain Moon Mart. So I'm going to save this file. I'm going to go back to my web browser. I'm going to refresh this page, and I'm going to say select star from Pokemart here. And now we have an entry in this database already to start with. So there's something there that we can begin to work with. Yeah.
So at this point, when we don't yet integrate all the database stuff in our phase one implementation, do we have like, should we have some hard-coded values for the things that we want to exist before the program starts to run?
So for your phase one implementation, my expectation would be that you're hard coding, like create an instance of this thing when this button is clicked. Yes. Yeah. And then they would just show up on the page. It's kind of hard coded that this is the thing that's there. My store has these two products and that's it right now. Or my clicker game has these two upgrades and that's it right now.
So the controller creates them with hard-coded by price and name.
Yeah. The controller is going to be responsible for just making those hard-coded instances for now. Yeah. Okay. I'm going to start inserting some stuff into this table now. So I'm going to say things like, I want to interact with the REPL, insert into Pokemart, name, values, Cerulean City Mart. And I can select star from Pokemart here. And I've got these two entries. And this is great. The problem with this now is when I hit Control R on my keyboard and I select star from Pokemart, the things that I've just done are gone. I've lost all that state. And that can be valuable. It can be valuable to lose all the state, but that's not really what we want to actually have in our applications. We want to retain state across refreshes of our pages. And each time I shut this down and start it back up again, I want to have that state back in my application. And so I'm going to go back to my editors here, and I'm going to make a change to this. The first argument that we can pass to this pglite constructor is information about where I want it to put its database, where I want it to actually store the contents of the database. The default behavior is that it stores it in memory. So when it loads the page up, it's just putting this all into memory and it's keeping it there while we're interacting with it. There are different places in web browsers, different kind of underlying technologies that we can use to put more permanent storage. And we're going to use one that's called IndexedDB as a backing mechanism for this. The way that we're going to say that is we're going to pass a string to pglite here, and it's going to be prefixed with idb colon slash slash. So this says now I want you to store this in the IndexedDB backing store for this web location. And I'm going to give this a name, 2452 Amon. So this is the name of the file internally that's going to be used. I would expect you to use your own app name for this as opposed to what I've just typed in here. But this is now creating this new pglite instance and making sure it's making sure that the database is going to be, persisted across refreshes. So each time I refresh my app now, after I've inserted something into this database, my expectation is that it's going to be there still because I'm no longer just storing this in memory. I'm storing this in an actual file that's kind of backed by my web browser. So I'm going to go back to my web page. I'm going to insert select star from Pokemart. I'm going to insert into Pokemart name, values, Cerulean City Mart. I'm going to select star from Pokemart. And I can see that I've got those. I'm going to hit refresh here. All right, something interesting has happened here, but if I say select star from Pokemart, it has persisted itself. So that's great. We've made like 2 steps forward, but only 1 step backwards. And the 1 step backwards here is, if I actually look at what this error is, this table Pokemart already exists. Yeah, of course it does, because I just made sure that we're persisting the changes that we're making to this database. If I run create table once, and then I try to run create table again, the table already exists. I can't make the table again. It would kind of obliterate everything that's in that table already. And so I'm going to make one last change to this setup here. The very last change to the setup is that I want to make these tables, but only conditionally. I only want to make them if they don't already exist. And so I'm going to add one small little statement here to my create table. I'm going to say create table Pokemart, but the structure now is I want to create this table if not exists. If not exists says if it already exists, just don't bother running the rest of the statement. Just stop. So I'm going to do this for each of the tables that we have here. And I'm going to comment out this statement. So I'm going to leave that commented out statement in there when I push this up so that you have a reference of where you could insert this initial stuff. But for now, I'm just going to leave it there. I'm going to go back to my web page now. I'm going to hit Control R on this one last time. We're no longer getting this exception being thrown because it's no longer trying to make those tables if they already exist. If I now say select star from Pokemart, then we still have those 2 rows. We still have the table that has been set up. We're in a better state than we were before. Yeah.
Having with that line for inserting Pokemart name there, like the console says that there is an error of duplicate key value violation. And like, how can we have a condition there as well that we insert something only if like that thing doesn't exist?
So this was why I conveniently commented this out before refreshing my page. So the problem with leaving this uncommented is the structure of the table that we have for Pokemart is that these names have to be unique. If I try to run this again, I'm going to get this exception being thrown. The options that you have for this, for loading default data into your database, are to like have a flag on a table that just says, have you done this already before? Have a check to see if you select from this table, does it have this kind of default entry already? And the last option is just to try and catch, try inserting it. And then if any of those statements fail, then just don't do anything after that. I don't think there's a best option here. The other option is just not to insert anything by default, but that's kind of a bad option in terms of we want to have stuff in our store. We want to have upgrades in our clicker game. Yeah. There was a question, I think, at the back. Was it answered already? Okay.
I think you were just doing for just demonstrate and training purposes already. Does it matter whether we have the console.log for our initial?
Does it matter if we have this console.log? No, I can comment out this console.log. Yeah, this.
I thought you were just using
it, the main purpose of doing the console.log was to prove to you basically that doing this question mark raw on this file name actually takes the contents of this file and puts it into the string. It's not a necessary thing for doing this. Yeah. Any other questions about this? Okay, awesome. All right, so I'm going to comment this out. And I do want to spend a little bit of time kind of stepping through reviewing some of the ideas that we have from SQL. So with that, I would like to actually start working with the REPL that we've created in our own application. And I'm going to close that developer console, and we'll just start working with our REPL here. So the table structure that we've got kind of reflects the state that we were in at the end of the last class. So I have things like Pokemart. So I can select star from Pokemart. And I've got 2 Pokemarts in my database right now. I can select star from trainer. And I don't have any trainers in my database right now. So I'm going to add one. Adding data into my database is insert statements, as we've seen. So insert into trainer. In between the parentheses after the table name, I'm putting the column names that I want to specify. So I just want to specify the name for this trainer. And the values are going to be, I'm going to insert me. So I'm going to insert myself into this table of trainers. I don't have a favorite mart right now. So if I select star from trainer, then I can see that I'm in this table, but I don't have a favorite mart yet. I can make changes to myself. I can say I'd like to add a favorite mart for Franklin. And so the way that I would do that is to say update. So insert is going to add this row to the database. Update is going to make changes to rows in the database. I'm going to say update trainer. I want to set, and then I have to specify the column that I want to change. So favorite mart. I have to specify the value that I want to change it to. To do this whole foreign key references this other table, I have to make sure that I'm actually using something that's in that other table. So I'm going to say that Mount Moon Mart is my favorite right now. And the last part of this is I've got to specify which row I actually want to change. Update by itself will just update everything. It will update every single row in the table if we don't specify which one it is that we want to update. And so I have to say where, and what we're putting after this where is the condition that finds the row or rows that we actually want to make changes to. So I want to update the favorite mart for the table trainer where the name of the trainer is equal to Franklin. Favorite mart, if I could spell it correctly. There. So if I say select star from trainer now, then I've changed that specific row in the database. If I add another trainer to this system, so insert into trainer name and favorite mart, values of Walter, and his favorite mart, we'll just give him a favorite mart by default, Cerulean City. If I select star from trainer now, I've got these 2 rows. If I do the update here without specifying where name equals, So if I just run this, that's going to blindly set every row's value for that column to be favorite Mount Moon Mart. So it will update everything. So I almost always want to have this where clause as part of the update statement that I'm writing. There are places here where we're going to have that kind of foreign key thing. We have to have these relationships set up. So I can't do things like insert into trainer name and favorite mart where the favorite mart doesn't exist. So this one won't work because that value of Viridian City Mart doesn't exist in the other table that we're referencing for the marts. Yeah.
So our favorite marks one is specified that it can't be null. Is it possible to set those values to null?
The favorite mart is nullable. So if I go back to my table structure here, favorite mart here is just of type string, but it is not written as not null.
So we could write in the grapple rings and we just write null on
So if I wanted to remove, I'm going to say update trainer set favorite mart equal null. This will just change everybody's favorite mart to null now. So if I say select star from trainer, now nobody has a favorite mart anymore. Yeah. I'm going to change this back. So update trainer set favorite mart. Everybody loves Mount Moon Mart. So I'm going to set all of them to be Mount Moon Mart now. The structure that we had for Pokemon was that if I select star from Pokemon, I'm going to be able to say that we have this nickname, we have an HP field, so this is some number, and the trainer, yeah. That's an excellent question. Is there any way to undo the changes? Yes. Yeah. We're not going to talk about that right now. We will talk about this later, but right now we're not going to concern ourselves with that. For now, we're going to say that the changes that we make, their effects are applied. And there is an erase like I want to undo, but for us, for right now, that's not something that we're going to consider. Yeah. So the answer to your question is yes, there is a way to do it. Okay. All right. That was awfully rude of me to do that, wasn't it? Yeah. So the context here is there's this idea of something called a transaction. So I can say I want to start a transaction. I want to make some changes possibly to this database. And I want to then be able to know whether or not these are the right changes that I'm making before I commit the transaction. Once you commit the transaction, there is no going back though. So there's no like recycle bin or undo after you've committed this transaction. Here, we're not doing transactions yet. We're just like every statement is being applied immediately upon execution. There's no going back after we've done that. The only way to really go back is to like restart everything again. Yeah. Okay, so I'm going to insert into my Pokemon table here. And what I want to insert into this is I want to have a nickname, I want to have an HP, and I want to have a trainer. So we have to have trainers. We've said that this is something that cannot be equal to null. The nicknames that we've got must be unique. So I'm going to say that this one is called Bulby. Its HP is 10 and its trainer is Franklin. So I want to make sure that I've actually got keys in that other table for this Pokemon. And I've got that Pokemon now in my database. I'm going to add one for Walter. I'm going to just bring this statement back up with my up arrow. And we'll call this one Charmy. Just like with our update statements, select statements can also have a where clause. And the where clause is going to allow us to filter out lines or filter out rows from this database. A typical operation that we would want to do is I want to get all Pokemon on the team for a specific trainer. So in our JavaScript and Java code bases, this is the collection that's contained inside of this trainer instance. But we don't really have that with the table structure that we've got. We've inverted these relationships. So now our Pokemon have a trainer. Our trainers don't really have any Pokemon directly. They just are owned. They have a set of Pokemon by the existence of rows in this Pokemon table that have trainer name for that thing. So for me to get all instances of Pokemon that belong to a specific trainer, I can say select everything from the table that's called Pokemon. And what I want to filter this by, so where, is where the trainer's name is equal to something specific. So I want to get all of Franklin's Pokemon from the Pokemon table here. The where statement is going to allow me to filter this on those specific rows. This is going to allow me to reconstruct that array that we've got in our database. You can also do things like trading Pokemon. So I'm going to say that I want to update the Pokemon table, and I want to set the trainer to be equal to Walter. I'm going to say that Walter's trading with me, where trainer is equal to Walter. So this is trading Pokemon from one trainer to another. And if I select star from the Pokemon table where the trainer's name is equal to Franklin, now I'm going to get all of the rows that are attached to me. So now I've got all these Pokemon on my team in the collection of trainers that I've got. The very last operation that I want to do here is I want to be able to remove records from the database. I want to delete things. The keyword that we're going to use to delete things from the database that we saw, I think we saw this last week, was I want to be able to delete things from the database. When I do something like this, delete from trainer, this is going to delete everything in the trainer table. Delete from trainer says, find all rows and remove them from this table. So just like we had with the update statement and our select statement now, we would want to specify which ones we want to delete. And the way that we're going to do that is with a where statement. If I delete from trainer right now, it tells me that I can't because there exist Pokemon. There exists some Pokemon that have references to rows that are in this table. And if I were to delete those rows, it would cause that reference to no longer work. It's going to break that reference. So it's not going to allow us to make that change to the table structure that we've got. If I select star from Pokemon, what I can see is that there are no references to Walter right now. So I can delete Walter safely. It's not going to have a problem with that because there are no references back to Walter. Walter doesn't currently own any Pokemon. So I can say delete from Pokemon, trainer, sorry, where name is equal to Walter. And if I select star from trainer now, then I've got just one trainer in my system. I've removed that reference to Walter. One of the things that I do want to model, though, is I kind of do want to be able to delete this trainer that's called Franklin. And if I am to delete this trainer that's called Franklin, I want to delete all of their corresponding Pokemon as well. I want to model ownership. I want to model composition here. I want to be able to remove references from this thing that exist when I'm deleting the thing that owns those things. So I'm going to go back to my slides here for just a moment. I'm going to skip down past all of these. These are, again, just a summary of some of the commands that we've been running. The last part that we want to do is I want to be able to make this set up so that if I delete my trainer, that it's going to also delete all corresponding instances of Pokemon for that trainer. The way that we're going to set this up is to use some additional keywords on the constraint, this foreign key constraint that we're adding to say, when the thing that this references is deleted, you should also delete rows in this table. So just like we've inverted the relationship between trainer and Pokemon such that the Pokemon know who owns them, we also want to say if the trainer is deleted, the Pokemon should delete itself instead of raising an error that we've got. We can still accomplish this by going through and deleting the Pokemon before we delete the trainer. I could say delete from Pokemon and then in a separate step delete from trainer, and we will accomplish that, but I want to make this easier on myself. So what I'm going to do is this. I'm going to say drop table Pokemon. This statement says remove the Pokemon table from the database. Now there is no Pokemon table. I'm doing this because I want to go back to my create_tables.sql and make changes to that table structure. So I'm going to go back to my project here. I'm going to make changes to this, and I'm going to say on this foreign key reference on delete cascade. When my trainer is deleted, when my trainer is deleted, I want you to delete the corresponding rows in this table as well. So any references to this now should cause that to be removed. I'm going to go back to my REPL. I'm going to refresh this page just to reload my database. I'm going to make sure that I have a Pokemon table. Good, so I've got this Pokemon table. I'm going to select star from trainer. I should still have Franklin here. Great. I'm going to insert some Pokemon back into this. Good. I can say select star from Pokemon. And now I can say delete from trainer where name is equal to Franklin. So remove this specific trainer. And if I do that, I no longer get these foreign key constraints. I don't have issues with that anymore because I've explicitly said if there's anything that refers back to this column, you should also delete those corresponding things. So now when I select star from Pokemon, there's going to be nothing in the table because we've deleted those corresponding instances. We have now forced composition to happen in this backing store. I can delete this object and everything that it owns. All right. Are there any questions about this? Yeah.
So do all users like share the same table, same database? If we open a new tab and like trying to
Yes. So your question is, do all pages, in this application share the same database? And the answer to that is yes. So if I were to come back here to my main page, and I'm just going to add something to, I'm going to open up index.html here, and I'm just going to put in the document itself this same thing that we've got. So I'm just going to copy paste some stuff. And I'm going to say pg.exec. We just deleted everything from here, so it's not going to show us anything as output. But if I were to do something like this that has actual entries in the database now, because both of these are using the same backing store, and they're also the same kind of root domain, so this local host, whatever, they're sharing the same storage in the back end. So our REPL is going to be able to interact with the same database that we're actually using in our application. Yeah.
Second question,
Yeah.
if we have two users that insert or create a Pokemon at the same time with same values, what's gonna happen?
So that's a very good question. What would happen if we had two different people inserting into the same table with the same values? The first answer is that's not going to happen in the apps that we're using because we're just doing local first. There isn't two users. Your web browser is the only user of this thing right now. If you have two tabs open and you are able to like quickly enough hit enter on the same query in both of them, the actual answer is one of them will win and the other one will lose. One will be able to insert that thing and the other one is going to fail to insert that thing because it will violate that unique constraint that we have on the table. All right, so I will share this code with you after class today up on the course webpage, up on the repository for this 2452 Amon. So you have a reference to the REPL that we've set up. I'm going to go back to my slides here, and we're going to shift topics just a little bit to start thinking about this idea of keys. So far in the setup for everything that we've done, I've kind of just told you that there are properties that we have on these classes that have unique values. We've asserted that these things are going to be unique across all things. The actual term for this is the key for this table. This is the thing that will uniquely identify this specific row in this specific table. So our Pokemon have nicknames. This is a decent value to choose as a unique reference for that specific table. This is a way for us to identify specific rows in a database. The thing that we've been talking about so far in this course are called natural keys. These are keys where we've got a property on this class that's really just unique in and of itself. So by its very definition, this thing about that class instance must be unique. It's just a thing that we can consider to be unique across all instances. Typically, this is also going to be something that will be defined by the user. They're going to give us this value, and it will be unique for them. It will also have some meaning for them. It's a name for the thing that we're working with. But there are sometimes places where we don't have natural keys. There are places where it's not reasonable to have natural keys. There are just objects that exist that don't have distinct properties about them. A banana doesn't have unique properties about it. I mean, literally, yes, every banana is different, but really a banana is a banana and it has some properties about it. It's got weight and it's got dimensions, but there's really like no name for a banana. I would feel terrible eating a banana if I gave it a name every time I ate one. And so if we don't have a natural key, we don't have a name property for this thing, we can come up with this idea that's called a synthetic key. Synthetic keys are going to be a property that we say has to be unique, but this is just something that we're making up. I'm just going to assert that I'm going to add this new property to this class, and I'm going to say that this new property that I'm adding to this class is unique by its very definition. So I'm going to add this thing to it. This is a value that our database will be providing for us. Our domain model will not make these numbers up. It will not make these values up. Our database has the responsibility of giving us a unique identifier for the row that has been inserted into the database itself. This is going to be meaningless for our users typically. My parents are not going to care what that value is once they get it. They don't really care what the identifier for that specific instance of banana is. They just know that there's a row in the database that represents that specific banana. If a class doesn't have a natural key, we're going to add the synthetic key that has the following properties. For us, it's typically going to be an integer value. This is not a universal requirement. There are other things you could choose for these synthetic keys, but we're just going to pick a number to represent this that starts at 0 or 1. We're going to choose a name that implies that it's being used for identification. And so a good name for this is ID. When we're marking up our class diagrams, we should add these where it's appropriate to indicate clearly that this is going to be the synthetic ID for this class, and mark it up so that it is unique. So using that tilde symbol to indicate that this should be unique. And for us, we're going to use a new type in our data definition language that's called serial. Serial is a new type. It is an integer type that we're using with the database that we're using. Different database systems will have different names or attributes for the thing that we're trying to accomplish with this. But for us, for the software that we're using, serial is the type that we're going to use for this. So I'm going to pop back to my browser here, to my REPL. I'm going to, again, drop table Pokemon. So I want to remove this. I'm going to go back to my SQL, create tables, and I'm going to change this structure. Nickname being the unique property is pretty restrictive because it means that you also can't have a Pokemon that's named Bulby. I think that's actually reasonable for us to want to have. So we're going to make a change to this to say that I want my Pokemon to have this new column that's called ID. It's going to be of type serial. It's going to be not null, and it's going to be unique. So this is going to be a key on this table. And I'm going to remove the constraint that the nickname itself must be unique. It should still be not null. A Pokemon must have a name. It must have a nickname when we create it, but it doesn't have to be unique anymore. I'm going to save this. I'm going to go back to my browser. I'm going to refresh this page. I'm going to select star from Pokemon. And now we have this new column in our table that's called ID. When I'm inserting things into this table, I'm not going to specify a value for that column. The value that is going to be put into that column will be provided to me by the database itself. The serial type says it should just be populated with a value when something gets inserted. So I've got, do I have any trainers left? I don't have any trainers. Insert into trainer, name, values, Franklin. And I'm going to say insert into Pokemon. I'm not going to specify a value for ID, so I'm not going to put it into the list of columns that I'm inserting into. Nickname, HP, and trainer. Values, Bulby, 10, and Franklin. And if I select star from Pokemon, this will have an ID of 1. This has been generated for me by the system. My database has generated this value for me. If I insert into this same table here with Bulby and 10 and Franklin, it's fine now because we no longer have this unique constraint on the nickname. I can insert this a bunch of times, and now I have many Pokemon named Bulby. And each of them has a distinct identifier here. Yeah.
Can we specify the ID manually?
If you specify the ID manually, then it's going to have to not conflict with the existing values because it is a unique value. If I specify 20 here, this will work because I've specified something that is not unique, or that is unique, sorry. And now if I insert something into this, it's just going to not use that value as it proceeds with that. I'm going to tell you that you probably shouldn't. If you're allowing the database to come up with this value, you should allow the database to come up with this value and not specify it yourself. We want the database to have the responsibility of coming up with these synthetic IDs for us.
Like, we want to update a specific row, we'll have to use this value, right?
If you want to update a specific row, you're going to have to use that specific value. So if I want to delete from Pokemon where ID is 20, I'd have to specify that. If I want to update Pokemon set nickname equal to Charmy where ID equals 7, I'd have to specify these specific things to distinguish or discriminate between each of the rows that I have in my database. Yeah.
So if I, the user, wanted to change something, since I don't have access to the ID, I'd have to check possibly 2 parameters.
If you're the user, you'd never see this ID. So when we're writing codes with our TypeScript code, we're going to have access to that ID. It will be part of the class that we're going to have. And we're going to use that as arguments that we pass around. I'm going to pass instances around. And when we finally get to the point of doing something with the database, we'll have to use that ID in the query that we're writing to make changes to it.
Okay, but if, for instance, you, Franklin, have Bulby, right? And then there is another trainer. If you want to specify that you want to make a change to yours, you have to check where the nickname is Bulby and where the trainer is.
So that's a fair question. If I wanted to make changes to my Pokemon, the flow of this really would be like, I'm going to find all the Pokemon that I own. And I'm never going to show you the values for other trainers because that's not your Pokemon. I'm only going to show you the instances of Pokemon that correspond to the collection that you would have internally in that object. If I wanted to make changes to Gary's Pokemon, there'd have to be some page for me to be able to accomplish that. But the pages that you would probably be making are going to just be for that specific person as opposed to broadly an administrative view that we're looking at right now. Yeah.
The serial data type is what's assigned inside this.
Yeah, so when we create the table with the serial data type here, when I've chosen this, that's what's going to be the thing that's kind of auto-populating the value in that column, yes. It's using a number internally in this database system. It doesn't necessarily have to be a number. This value really should be opaque to us, and so what I mean by that is we shouldn't infer any meaning from that value. Conveniently for us, it is sequential, so we can say things like, I can order by ID, and then I know what order things were inserted in the first place, but we shouldn't infer any meaning from these values. They are meant to be used internally by the database to discriminate between rows in the database. Okay, all right, awesome. Here's the last thing I want to talk about in terms of like setting up structure for our data model. We now, I think, have a pretty clear idea of how to go from class structure, so class diagrams, we've got TypeScript classes, and now we can create tables that reflect the state of what those classes are supposed to be so that we could, in theory, start putting data in our database to represent those things. But we're using TypeScript and we're using languages that have class inheritance and interfaces. And so how do we go from subclasses to tables? And we're going to use SQL, but we're going to begin to wonder why we're using SQL to accomplish this task, because doing this mapping from subclasses to table structures is not really super straightforward. This is that object relational impedance mismatch. So far, we have solved this problem of collections. We inverted that relationship, and now we can model the relationship between an owning instance and everything that it owns by saying that the things that it owns are owned by that thing. We've kind of done encapsulation, but only by like constraining which ones we're selecting. I'm only going to give you access to the things that you own in terms of you as a person in this system. And polymorphism is something that we haven't really addressed here, and that's what we're going to think about right now. Our model so far is basically, I want to take a single class and I'm just going to map that to a table. I'm going to make a table structure to represent that, but generic classes and generic collections and subclasses are a little bit less straightforward. We've got two major options to accomplish this. One is I want to make one table per subclass. The other option is I'm going to flatten that entire class hierarchy into one single table and put everything into one single table. Having one table per class is pretty straightforward because it's kind of consistent with the model that we've got right now. I have one class and one table, and we've got this one-to-one relationship between our class definition and the table definition. This is straightforward to understand because it's exactly the same pattern that we were applying before, and that's a good thing. But loading collections now that contain all of those types, we have this superclass, we have an array of those superclasses or the instance interface. Loading that data can be kind of painful. Why though? Why is it painful? The problem is that if I want to load a trainer and all of the items that they have, and so this is now going back to Comp 2450, item was an interface that we had, and we had a bunch of implementations of that interface. If I want to load every single kind of item that this trainer can have, I need to load the trainer from the database, and then I have to go through every possible table that has all of the different kinds of things that this trainer could have, even if they don't have any of that kind of thing. If they have potions, I have to select from the potions table. If they have ether, I have to select from the ether table. Even if they don't have rare candy, I have to select from the rare candy table to be able to know whether or not they have rare candy in their collection of items. This is actually fine if we only have 2 different subclasses, but if we have many different subclasses or implementations of this interface, now we're going to have a problem. I'm going to argue that you have different problems if you have 30, but you're going to have a problem with this. The other option is to flatten all of this class hierarchy into the same table structure. And that really means that we're going to be able to get this nice property of, if I put all possible things into this one massive table, I can do one select and I can get everything. I can get every implementation of that thing. But it doesn't really fit into that one class per table convention. And my answer to that is, whatever. That actually doesn't really matter that much in terms of making decisions about this. The real problem is that we can't discriminate between types in the rows in a straightforward way. We're not able to know what kind of thing this specific row is in all of the things that we've got. We can solve this by using this idea of a discriminator column, and we're going to add a new column to the table that just represents this is what kind of thing this happens to be. But the problem really now is that the tables don't have infinite columns, and that's a bit of a problem. When I create this table, I'm going to have to make all instances, all properties for all subclasses. I'm going to have to make a column for every one of those things. This is harder to include constraints, and I'm just going to stop because we're like right at the end, and I'm racing through this. We'll finish talking about this on Thursday's class. But at this point, you should really be able to create, populate, and query data in a database. So we've exhaustively gone through all sorts of different kinds of statements that you should be able to use to create database tables and get data back. We're starting to be able to use a programming language to interact with a database. So at this point, you should be able to take your table structure and cause it to be created in the web browser using this basic setup and interact with it with that REPL. That's it for today. I will see you all on Thursday. Bye, everyone.